right, welcome to your last lesson for this week, guys. Tomorrow will be a review day, and you will not be watching notes or doing any lessons. So let's jump right in. So today we're going to talk about equations with variables on both sides. Remember that a variable is a letter that we designate to represent a number or an unknown. So let's do number 18 together. Please take notes as we do this. As you can see, I've rewritten it, and I want you guys to do the same so that you can get that practice. So the first thing we're going to do, like usual, is we're going to draw our river through the equal sign. And we're going to check each side of our equal sign to see if there are any like terms that we can combine. And remember, like terms are two variables that are the same that we can add together. So on the left side, I can combine 5.3x and negative 4.1x. Remember that subtraction and negatives are the same. We think of them the same way. So I'm going to add 5.3 plus negative 4.1. And what I get is 1.2x plus that 2. Notice I cannot combine these together as one has an x and the other does not. Okay, on the right side, I cannot combine anything together, so I have 3.6x minus 1.6. Now at this point, I need to make sure my variables are on the same side of the equal sign so that I can solve for what my variable is, and I typically like to move my smaller variable. So when I look at 1.2 and 3.6, 1.2 is smaller than 3.6, so I'm going to move this variable over to the opposite side. Opposite of a positive is a negative, so I'm going to subtract 1.2x from each side. Make sure that you show your work as we're doing this so that you don't make silly mistakes. Anything minus itself is 0, so I have 2 equals 2.4 times x minus 1.6. Now at this point, I have a two-step equation. I'll circle my variable, move my constant by adding 1.6 to each side. And 2 plus 1.6 is 3.6 equals 2.4 times x, and negative 1.6 plus itself is 0. And my last step is just a one-step equation where I divide each side by 2.4. And my answer is 1.5. So 1.5 equals x. Now, to save time in the video, we're not going to check our work, but if you wanted to check your work, you could plug in 1.5 back into the equation for your x's and check to make sure that both sides were equal. All right, let's try one more. Number 20, 2/5 times c plus 4/5 times c minus 6 equals c plus 7. Now I'm going to have you make sure that you write this problem down below so that way you can show your work and make sure that you give yourself some space so that we can get rid of our fractions. Now the reason we want to get rid of our fractions before we solve this problem is because when you get rid of fractions in an equation, it just makes the whole process easier. Now I need a common denominator, and that's pretty easy to find because both denominators are 5. So I'm going to multiply every term by 5, or I could also say by 5 over 1, which is the same as 5. Again, make sure that you show your work for this so that we are less likely to make silly mistakes or forget something. Okay, the reason I am multiplying each term by 5 is so that I can cancel out of my denominators and get rid of my fractions. So let's work from left to right and rewrite the problem. My 5's cancel out. 1 times 2 is 2 over 1, 2c is what I'm left with. Now I'm going to take care of my second term. My 5's cancel, and I'm just left with a 4c over 1, or 4c, and then I've got my minus sign. 6 times 5 is 30, so minus 30. Now on the right side I have c times 5, which is just 5c, and then I have plus 7 times 5, which is 35. Now at this point I have gotten rid of my fractions, so what I'm going to do next is I'm going to combine my like terms on each side of the equal sign. So on the left I have a 2c and a positive 4c, and 2 plus 4 is 6. So 6c minus 30 equals 5c plus 35. Okay, now I would like to combine my like terms, but these are on opposite sides of the equal sign, so I need to use inverse operations to move my smaller variable to combine that with my larger variable. So out of 6c and 5c, 5 is smaller than 6, so I'm going to subtract, because the opposite of a positive is a negative, and negative and subtraction are the same. 6 minus 5 is 1, or just 1c. Minus 30, I'm rewriting my problem. These are 0, equals 35. Now my last step is to add 30 to each side to undo that negative 30. Negative 30 plus 30 is 0, and I'm left with c equals 65. Again, like I said previously, we are not going to check our work, but if we wanted to, we could just plug in 65 back into the problem. So I would have 2 times 65 plus 4 times 65 minus 30 equals 5 times 65 plus 35. Okay, to wrap up these practice questions with equations, we're going to try a couple more, and I'd like for you again to add these to your paper as we are practicing these together. Okay, so let's go ahead and try number 19. So this is negative 2.2 plus 0.3z equals 3 minus 0.5z minus 0.8z. Okay. Now, I don't remember if I mentioned this, but this is lesson 8-5 in your book. Okay. So again, we can see we have variables on each side of the equal sign. So before we try to get our variables together, we want to combine like terms. On the left, I have negative 2.2 and a 0.3z. These are not like terms, so I cannot combine them. On the right side, I've got 3 minus 0.5z minus 0.8z, and I have two like terms, meaning I have two terms with the same variable. So I can add negative 0.5z plus negative 0.8z. Now make sure that when you combine your like terms, you rewrite the equation with your like terms combined. Now negative 0.5z plus negative 0.8z is a negative 1.3z. So when I combine my like terms, that's what I get. Once I've combined my like terms, I can move my smaller z to the opposite side so that my z's are together. And opposite of a negative is a positive, so I'm going to add 1.3z to each side. Again, I rewrite the problem after I've combined my like terms. So I've got negative 2.2 plus 1.6z, and on the right side I'm just left with a positive 3. Now at this point, this is a two-step equation, 2 steps to get the answer. So the opposite of a negative is a positive, so I'm going to add 2.2 to each side. That's 0, and I have 1.6 times z equals 5.2. And my last step is to divide each side by 1.6. Now you are allowed to use a calculator. These problems will take a pretty long time if you don't, so that is absolutely fine. Anything divided by itself is 1, so go ahead and cross out your 1.6 divided by 1.6. And 5.2 divided by 1.6 is 3.25. So that's what my variable z equals. Okay, let's try one more problem with fractions. So I've got 1/8 m plus 2/5 plus 1/2 m equals 3/8 times m plus 3/4 times m. Now again, notice how we have fractions. So what we want to do is first draw our line through the equal sign, and we want to figure out, trying to draw a straight-ish line, we are trying to figure out what our common denominator is. So I think that we can use 40 because my common denominator of 8, 5, and 2 and 4 is 40. So I'm going to multiply each term by 40/1. Okay, notice how I have to do this to each term to keep my equation balanced. Now I'm going to cancel out. This is the fun part. 40 divided by 8 is 5. So I'm left with 5 times 1, or 5m. Then I've got, again, 40 divided by 5 is 8. 8 times 2, or 2 times 8 is 16, so plus 16. 40 divided by 2 is 20, so I'm left with 1 times 20, and then my m. Okay, now on the right side, again, I'm left with 40/8, which is 5. 3 times 5 is 15, and with my m, I can't forget that. And 40 divided by 4 is 10. 3 times 10 is 30, and I also have my m. So I want to combine like terms now on each side. So 5m plus 20m is 25m. Plus that 16 on the left. And on the right side, I have 15m plus 30m, which is 45m. Now I'm going to subtract each side by 25m so that my m's are together on the same side of the equal sign. And I'm left with 16 equals 20m. My last step is to divide each side by 20. Anything divided by itself is 1, and I have 16/20 equals m. Now, because they gave me this problem as fractions, I want to leave my final answer as a fraction, but in simplest form. So I can divide 16 and 20 by 4/4, and my answer would be 4/5 equals m. All right, so that is all for these equations with variables on each side. We are going to do another example together that is a word problem because you will have some homework that will require you to write equations with variables on each side. Nice job, guys. Thank you for listening, and I'll see you in the next video.